Hello everyone, good morning. Dear authors and invited guests, welcome to the technical session 4D. Myself Prashi and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th edition of the International Conference on ICT for Sustainable Development ICT4SD 2025 Goa, India. The 10th edition of this conference is being held in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries, then you can write it to me in the chat box. Just before we start the session, our session chair will be joining us a little bit later. So we'll just start on with our first presenter. Our first presenter is Palak Patil, presenting a paper on the title Adaptive Key Authentication for Secure IoT, Addressing Security Threats and Optimizing. I request you, if you are available with us, kindly please take over with your presentation. Ms. Palak Patil. Ms. Palak Patil, if you are available with us, I request you to kindly
Yes,
take
yes.
over.
Am I audible to everyone?
Yes, now you're audible, ma'am.
Okay. So, hello everyone. I'm honored to be here today to present my work on adaptive key authentication for secure IoT, addressing security threats and optimizing. As IoT becomes more integrated into healthcare system, there is the need for robust, efficient security mechanism that becomes critical. Growing connectivity in IoT means that sensitive medical data is also vulnerable to numerous security threats like man in the middle attack, key theft, and device cloning, among many others. These traditional methods for authentication based on either password or static keys are especially susceptible to such cyber attacks. They are ineffective in protecting healthcare IoT environments characterized by dynamic threat landscapes. So my this research article presents a new dynamic key-based authentication scheme for healthcare IoT networks. So in my suggested framework, mutual authentication between each of the healthcare server and the physical IoT client device is used to protect the sensitive data of the patient. So in IoT device, it has low computational capacity, low storage capacity, and they are battery powered. So it has they are optimized for low energy consumption. So it is also so the protocol should be lightweight enough for constraint medical IoT devices, and the protocol must be lightweight. So this system is efficient with respect to the data size between the registration and authentication phases, while performing better than all existing other systems. It also minimizes latency and bandwidth uses by improving the each layer. So this scheme is also cheap, computationally cheap, making it feasible in resource-constrained healthcare settings. And the security analysis tools confirms that the suggested architecture is resistant to ordinary attacks, such as man-in-the-middle attack and replay attacks. So before heading to literature analysis, I would give shadow on existing authentication methods. So these are the existing authentication method. One is identity-based authentication. It is widely used with username, password, and fingerprint. Uh, One is token-based authentication, in which token is given to the user by the central authority, like employee ID given by the organization. Next is hardware-based authentication. That is like a we can say PUF-based approach, that is physical unclonable function. It works on challenge response-based model. Next is context-based authentication. In this authentication, it is furtherly classified in the physical authentication and behavioral authentication. Physical, we can say it is authenticated with the location of the node, and in behavioral authentication, we can take an example of radio frequencies signals, because each channel has different characteristics. So, depending on the characteristics of the channel, the authentication is done. Next is procedure-based authentication. In procedure-based authentication, that is two types of further classified. One is one-way authentication, and second is two-way authentication. In one-way authentication, client authenticates server. Sorry, server authenticates clients. In mutual authentication, each entity authenticates each other. Means client authenticates server and server authenticates client. So now I am heading to literature survey. I have reviewed different articles, that is work done in particular authentication in healthcare domain. So in this different paper, two-factor based authentication is used. That username and password smart card based attack is used. So they are this method is vulnerable to very power analysis attack. Next is password, and next paper uses password and smart card attack. Smart card attack stores this kind of valuable information, so it can have a chance of single point bottleneck attack. One paper is used the blockchain technology. So in the blockchain technology, storage is a hurdle. So blockchain technology, because IoT is as a resource constrained environment, so blockchain technology will face the difficulty in this particular approach. So one paper has used the PUF-based authentication. So hardware-based authentication uses the challenge response model. So in this model, in this particular paper, modeling attack is possible. So in different, and one paper has used a Diffman-Hellman algorithm, that is asymmetric algorithm. Asymmetric algorithm is also very difficult to implement for a resource constrained environment. So in from this all paper, I have research gap. I found this research gap is that most of the authentication methods are mostly uses single key based approach, password based approach to authenticate the participant entities of the network. So such kind of methods are vulnerable to key stolen attack, side channel attack, and man in the middle attack. And so most of the method uses same password-based approach through the authorization process. So there is a need of dynamic key-based approach for a effective authentication method. So this is the my system flow. Some first of all, user will do with registration with the server. So user ID and password will be stored to the server. Then will authentication come in the picture when user tries to log into the server, and it will send the login request to the server. First of all, server will check for the user ID. If it is that particular user ID is stored in the server previously, then it will go for the further authentication. Otherwise, it will terminate the session. If it is if user ID is valid, then it will go for the dynamic key based authentication, and then the further communication will be established. This is my algorithm's proposed structure, in which main two entities are there. First is IoT client and next is server. IoT client is first of all send the user ID and password. It will send the request in message digest value of user ID and password along with the session number. Server will here in this my protocol mutual authentication is done. So server will I have used here 8 by 8 matrix of wall table that uses different 64-bit values in wall table. So from this table, server will make a challenge, eight different values, eight different keys as a challenge, and these 8K keys will be sent to server to client as a challenge, and random number is also generated as server side. So this message M2 will send from server to client, and at client side, client will fetch the values of of eight these different key from these different eight indexes, and XOR operation will be done on particular these eight indexes, and these from these eight indexes by XORing operation the key will be generated, and this key is key here the key is not stored at any client or server, runtime key is generated. So this key will be using for the encryption purpose, and client side also one temporary nonce is also generated that will be used for further session key generation. And so from for response to the server, client will generate a response by encrypting key of a random number one and temporary number one, and it will also send a challenge for the server. Now here at server side, server will check for the response that is sent by client, and for server side it has the same indexes and same the value, because vault table is stored for at both the side clients and server. It has the same key that has client that client retrieve. So with the same key, server will also generate the same key that client has. And if server is getting the same random number by decrypting the message that server has sent earlier, so here it proves that client is the authenticated. Now server will generate 64 bar nonce value, and it will send to client. And at the server side, server will also generate a response to the challenge message of the client that is generated by the client. And these eight
Excuse me, ma'am. I'm sorry to
sorry.
interrupt you, but we have crossed the 9-minute mark. This is just a gentle reminder to you.
Okay, thank you, ma'am. Okay, so in this way, client is authenticated server and server is authenticated client. After mutual authentication, further session key is generated between temporary nonce generated at client side and server side. XORing of these both values, the session key is generated. So here I have implemented this algorithm in Avispa, that is push button tool, and I have cross verified these with both the backend, that is OFMC checker, and one is CLATCA checker. In both the checker, I have it shows here this screenshot shows that this protocol is safe against this reply attack and MITM attack. And I have also compared these registration phase cost value and authentication phase value in the terms of bytes, because the IoT be resource constrained and it should occupy lesser bytes. So in this table, from this table, you can see that my system is occupying less bytes in registration phase also and authentication phase also when comparing to existing approaches. So this is the communication cost analysis, and this is the computational cost analysis that I have also compared this my approach with the previous papers. And different papers have occupied these 2 TH plus T Mac TH Mac plus 2 ETD. This much computational cost has occupied. So here also you can see that my paper occupied lesser computational cost when comparing to previous papers. So yes, madam, sir, so here I'm concluding that the system also optimize my system competence at the both phases, lowering the communication overhead to 33 bytes for the registration phase and the 4 bytes for the authentication phase, which results in the decreased latency and the less bandwidth use. Thank you.
Thank you so much, ma'am. We have our session chair over here. Doctor, do we have any questions for her?
For optimization, which technique you are used?
Optimization, I can say, ma'am, I've measured it in terms of communication cost and communication cost. This is for communication cost. I have just calculated the bytes as per the like nonce is generated, and the other temporary keys are generated, random numbers are generated. So with this calculating cost of all the particular variables, I've concluded particular bytes used in my protocol.
Okay, thank you.
Okay.
Thank you so much,
Okay.
ma'am.
Thank you.
Now, before we go on to our next presenter, I would like to introduce you all to our session chair, Dr. Latika Desai. Dr. Latika Desai at present is working as a HOD IT department, Dr. D.Y. Patil College of Engineering, Akudi, Pune, India. She has total 25 years of teaching experience. She has published 33 papers in various journals. She is having two copyrights from the Government of India. Her area of interests include digital electronics, data security, and embedded systems, IoT cloud. We welcome you to the session, ma'am. Would you like to say a few words before we go on to our next presenter?
We'll go to the next presenter. I will give my comments at the end. Okay. Thank you.
Okay, ma'am. Thank you so much.
Continue.
Now I'd like to call upon our next presenter. Ma'am, with your due permission, we have a situation with our presenter. Can I take him first? He's written that on the chat box as well.
Okay. Okay. No worries.
For sure. Thank you so much, ma'am. So I'll just call upon our next presenter. Our next presenter is Amitabha Bhattacharya, presenting a paper on the title Graph Database Comparative Study of RDBMs and No-Queues. I request you to kindly take over with your presentation, please, sir. Excuse me, sir.
Am I audible?
Yes, sir. You're
My dear Dr. Latika Desai, anchor of ICT for Sustainable Development Program on 17 July, Goa. Maybe it's a good happening over there. My brothers and sisters, this is Amitabha Bhattacharya, served 31 years for my motherland, being an IIT MTech, and now I'm representing on behalf of Adamas University, NAC A grade, Barashat, Kolkata, West Bengal. Research community will be thrilled after seeing the industry practices as well as academics. My subject is in graph databases. I have presented earlier in IEEE and Springer also in the same Revard Joshi's GR Scholastics Excellence. So I may give acknowledgement to our Honorable Chairman and Chancellor, Dr. Professor Shomit Ray and Dr. Radha Tamal Goswami, Pro VC, and Vice Chancellor Suranjan Das. My graph database is nothing. It's a survey we have done in IEEE. I have presented there. And there we are seeing few graph databases are coming in the market and it is going back from vanishing from the market. So what needs to be done? So lot of graph databases has come into the picture, Redis, Ria, Hadoop. We are seeing Amazon DynamoDB. We are seeing Cassandra, lot many things, say MongoDB. So I'm talking about MongoDB's future, and we have done the analysis for comparative study of graph databases versus SQL and NoSQL. There are some problem. Problem is complex join. So to avoid that, NoSQL is far better for industry practices nowadays.
uh,
So I'm just open the
excuse,
slides. How do I open the slide here? Is it shareable? Can you see?
yes, sir. We can see it.
So graph database comparative study of RDBMS versus NoSQL. Everybody knows that graph databases are trending marks for storing data and retrieval. I am Assistant Professor, Department of Computer Science of Adams University. So, next slide, how should I go? Of acknowledgement, Chairman and Chancellor of Adams University, Dr. Professor Shomit Ray of Adams Brand and Rice Group. So this is the basically Amazon, Neptune, OrientDB, Janus graph, Auranga graph, lot many graphs are coming. So we have done a survey in IEEE 2021 and I have presented there. So this is the R angles model of key value stores, big table clones, document database and graph databases. Data complexity differs with data size. So you see how many graph databases are coming and going from the market. So MongoDB it has a future. So when I was in IBM, AT&T, and Tata, I have seen that it is being used. So here is the network diagram. Everybody keeps the database in relational database model, but for complex query and the total model of the architecture, the graph, the pictures cannot be kept in proper place. So MongoDB is the best place to develop network equipment databases. So this is the switch that also a different model that we can store in MongoDB. Survey of graph databases, I have told, moving away from RDBMS and graph database use case, a Mumbai local train. That graph database also can be developed instead of relational. Network DB creation via MongoDB. MongoDB Compass is there. It's a free. MongoDB Atlas is also free. So you can explore. My main research area is, this is the Oracle legacy that I have developed long back. Can anybody shift this relational database of telephone directory integrated with my payroll can to MongoDB? My still answer is no. No one could compare. So my paper consists of 3 parts. One is survey, second is re-engineering methodology from SQL to NoSQL, and third part in Springer with the blessing of Dr. Joshi. I am publishing this paper. How faster is the MongoDB compared to your relational databases? This is my thirst. And thirst is, there is a evolution of graph RAG and as well as large language model. One day we can see future scope that in one graph databases there is a payroll system, another graph databases we develop by our own say telephone directory without any SQL. My imagination, my firm belief that there will be no SQL-like or NoSQL-like syntaxes is required if I put one DB in one graph RAG and another graph RAG, and you just see, you tell large language model that you just give whether this record consists this particular element or not. So this is my imagination, but nobody could do it yet. So this is the create table employee. So we know foreign key, this thing. This is unnecessary. This is also evaluation. Since the time constraints is there, I am bound to finish within the speculated time. So MongoDB and Oracle, this is particular the document, and this is a table. So here, once Oracle databases is freezed, you cannot change the particular item. And whereas in MongoDB, you can add, say, mobile number and location later on also. There is no problem in MongoDB. So there is the advantage of MongoDB. So here we see Cassandra, React, Redis, CouchDB, everything is there. So my next part is re-engineering the syntaxes, the operator. So select command is DB collection. Like that, all the things have been given in the paper. So people will be get interest how to reverse engineer the SQL databases and map it to NoSQL. You don't throw out whole the legacy system. As a practitioner in Tata Technologies, and I was a practitioner of Telcon, IBM, AT&T, you don't throw the system at all. You just try to reverse engineer and get the table, DB space, the indexes, then DB connection. You take information about little bit of some of the uh, Unix environmental variable and map it to MongoDB. It's very easy in MongoDB, either CSV file or JSON file. With JSON file and CSV is there, if you can bring out this record and import in MongoDB campus, it will be very nice, but nobody could do it yet. So it's a research area, future scope. I told that one day there will be no SQL, no SQL syntax will be there with large language model when it is coming into the picture. It's imagination. Don't think otherwise. The DB collection find is also there on column 2. We can do operator syntax.
Excuse
So
me,
this is
sir.
also SQL operator.
Excuse me,
Yes,
sir.
about
This is just a gentle reminder of the 9th minute mark. Please
oh, I
continue.
see. So here I just want to finish that the graph database evolution is there. So here I want to show I can make it big. So here the number of records I take from relational, and for insert, select and update and delete. This is my focus area for this particular Springer applications, Springer's events. It's a big events. I know in Goa, I could not go. I'm very upset because of rain and other thing. But this particular execution time with no number of records in MongoDB, how much time it takes for insert, select, update, and delete. This is my focus area for this Springer application. How to do that? Dr. Lotika will definitely appreciate that with this particular method, we can take out the time of insertion, select, update, and delete. My revered Dr. Latika Desai, I should not conclude here. I just give me 1 minute time. This is a MongoDB, this particular snapshot. I just want to show the Mumbai, this particular Mumbai local train can make it with MongoDB, and there is a future with the advent of big data, social enterprise data, industry data, spatial data, then raw data, blockchain data, and corporate data, web data. With the event of big data, then search engine will be puzzle. So there will be a category search that I have mentioned in my paper. With this, I give you the distinguished guest and my brothers and sisters and my research fraternity so that I can write paper, give me blessing at the age of 57 years. I served my motherland in India. I am happy that from Switzerland, it got accepted by GR Scholastic. Thank you, Dr. Joshi and Harsh Shoni and Prachi for giving me the opportunity since power will go away. Thank you.
A fruitful session, sir. And old is gold, you are said with this presentation. We all will follow. Thank you.
Thank you, Dr. Latika Desai, for your valuable feedback. Give me inspiration so that I can give GR Scholastic again with some idea.
Yes, sir. Yes, sir. You share your number. I will be in touch with you. Okay. Thank you.
I'll search in your with your LinkedIn.
Okay.
Thank you so much, sir, for your presentation. Now moving on to our next presenter. Our next presenter for this session is Yash Shekhawat, presenting a paper on the title American Sign Language Recognition Using Hybrid Deep Learning Architecture. I request you to kindly take over with your presentation, please.
So, hello all. This is Yash Shekhawat. I, along with my teammates Rahul and Abhijit, have submitted this paper on real-time sign language detection using deep CNN LSTM architecture with the supervision of Dr. Naresh K. He's also a professor. So, sign language is an essential medium for individuals with hearing or speech impairment. Despite its importance, many face communication barriers due to limited public knowledge of sign language. So, our project addressed this gap by creating an inclusive and real-time system. So, coming on the literature review, what has been done till now, previous studies have explored sign language recognition using deep learning and computer vision, like CNN, MediaPipe, projects such as With You or Cigna Spectrum. They achieve real-time gesture recognition using ISL and ASL. ISL being the International Sign Language and ASL being the American Sign Language. So our dataset was mostly of, like, we prepared our own dataset according to American Sign Language because that's the benchmark to judge, focusing on static and dynamic gesture. Now they have been using LSTM. They were using CNN or just the LSTM. They didn't integrate. So our project worked on integrating LSTM with CNN. They were also using MediaPipe. So while we are using MediaPipe, we need not to use CNN because MediaPipe will automatically extract the data, but it will limit the use case and also decrease the accuracy if we use just a MediaPipe. So we have integrated CNN along with LSTM, LSTM for the time series data and CNN for getting the features from the image. This is the model architecture. If you see, these are the CNN models: input, then convolution model, pooling, then fully connected neural net, along followed by two LSTM layers, then two dense layers. We have achieved an accuracy of 94% on our dataset using this, where the market standards like previous, they were achieving approx 84% accuracy without using CNN or the standalone LSTM or the standalone CNN. This is a confusion matrix, if you can see. We did it on 11 datasets. And so what we did was, if we are using LSTM is a time series based neural net. So we need to give a set of images. CNN will just take a one image and extract the data. But LSTM, we gave a series of 48 cross 48 pixel, 10 grayscale frames to extract a time series data, like how what's the relation between all the images. It will be extracted, then it will go on. Now we using this, we had accuracy of approximately 94%. And coming on our further, like future scope, like features, there are few feature scope. One is simply integrating PTA, that is text to speech, for like people with like viewing impairment, so that they can hear what the sign language is being detected, like what they are being told. It could be just went to TTS. And another that could be reversionally is using pred-RNN. Pred-RNN, like it's predictive RNN, that's still under development, but it's showing good results. If we integrate predictive RNN, it will, like, accuracy will go till like 98 or 99, because pred-RNN sample is using video samples. If you give video samples, it will again break into, it will then again work like LSTM, but it is predictive RNN. So if you give 10 samples, it will predict the 11th one. So it will reduce the need of too much data sets, and within limited data set, it will go good results. If I show you the paper and some, these are the related works: vision-based CNN, LSTM only, sensor-driven, that is electronics. No, not the integration of LSTM and CNN. This work was not done. This is a methodology how we collected the data. If you'll see, this is in American Sign Language. This is 6 2. This is B. Coming on models architecture, these are the sigmoid and 10H function that we used. LSTM consists of OR gate and input gate. This is a deep LSTM, basic LSTM architecture. These are the excuse me. These are the layers that we use. First is CNN, then pattern layer, LSTM1, LSTM2. So I showed you here also. Sorry, this one. So 46 cross 46 is a size. We are using 10 kernels. I'm sorry, 32 kernels. Then there is pooling layer and fully connected layer. And when it comes to here, the size is 10 cross 16, 19, 28, 16, 9 to 8. And at last, size is reduced to just 11 outputs, just like how neural net functions. So our project mainly worked on integrating both CNN and LSTM. This is a pseudocode how this will go. You are currently working with grayscale, because grayscale you will not have many variables like color confusion matrix. These are the grayscale images, 48 cross 48. Yeah, that's all. Have any questions?
Which data sets you are use here for your implementation?
Datasets, like we took reference from how ASL it is. Like this is A in ASL. We made our own dataset
Okay.
because using that we
Topic.
can control many variables. And
Okay. So how much data sets you are handled till?
we had approximate 300 images of per, including testing and training, 300 images of per word. Like for A 300, for B 300. We use a train and test split of 0.8 is to 0.2 at 80 and 20.
Okay. Topic is very nice. It is for societal
Yeah.
use. Thank you. Thank you.
Thank you. Thank you for your kind words.
Thank you so much for your presentation, sir.
Thank you, Prashi.
Now I would like to call upon our next presenter. Our next presenter is Ritika Soni, presenting a paper on the title From Scroll to Screen, Emotional and Psychological Physiological Engagement in Text, Comics and Virtual Reality. I request you to kindly continue with your presentation, please. Ms. Ritika Soni.
Yes, ma'am. Am I audible, ma'am?
Yes, ma'am, you're audible.
Hello, madam. Am I audible?
Yes, ma'am, you're audible. And your screen is visible to us.
Thank you so much. Good morning to the chairman and everyone present here. My name is Vitika Soni and I am from Indian Institute of Technology, Mandi. Today I will be presenting the paper titled From Scroll to Screen, Emotion Physiological Engagement in Text, Comics and Virtual Reality. Done under the guidance of Professor Barundar. This study has been done in collaboration with Mr. Harshu Mohan sir, who is graphic illustrator and novelist. So starting with the introduction, so there has always been a high attention focused on VR's immersive potential, and it always said that VR has the capability of telling in the deeper emotional engagement pattern is always reflected in the VR's potential. But a study conducted by Sweller says that VR's immersive potential doesn't always translate to deeper emotional engagement. In fact, higher cognitive load may hinder absorption. On the other hand, text and comics harness mental imagery and dual coding to reduce extraneous load and enhance effective responses. Here, the dual coding means text and images. So, in the comic pattern, we always have panels in which there is image in the background, and in the text format, we have the captions which are written to make the image suitable and visible for the viewer to view. Narrative coherence and pacing in simpler media support sustained reflection and emotional regulation. The prior work treats each medium in isolation, relies on self reports, and rarely uses culturally grounded story or physiological metrics. So we aim to compare the image engagement with the Harish Chandra narrative across text, comics, and VR using the self-assessment mannequin, which stands for SAM, and facial thermography to test whether the simple media can match or access VR in the sustained emotional involvement. So the background is uh, that text and comics leverage dual coding and mental stimulation to engage both verbal and visual channel, reducing the external load and enhancing emotional processing. Immersive VR environments, while attention capturing, can exceed working memory capacity and fragment narrative absorption under high cognitive demand. Narrative transportation theory suggests that coherent paced storytelling fosters deeper empathy and belief change, advantages more readily sustained in text comics than in highly interactive VR. The objective physiological metrics such as heart rate variability, which stands for the heart rate bit of in the individuals. We have taken two characteristics, RMSSD and LFHF ratio, and facial thermography offer direct insights into the autonomic regulation and emotional engagement across this media. So the objectives is, so we have tried to analyze the narrative impact. How do text, comics, and VR formats influence emotional responses to the culturally grounded Harish Chandra story? We have tried to measure the engagement, to measure the emotional involvement using the both subjective and objective metrics, and compare the format efficacy, where we are evoking the stronger emotional reaction than VR environments. So in this, so the study design and procedure, we have tried to take the 30 participants, 10 participants per condition, and we have tried to take the Harish Chandra Tail Course Spaces Education on MetaQuest 3S. We have used this virtual headset. And in the comic medium, we have professionally illustrated graphic novel version. And in the text medium, plain text story was shown on the mobile devices. So the procedure was after the participant came in, 5-minute neutral rest was given to the participant to remove the accumulation. And then we have started collecting the HRV through EM Wave Pro device and administrating the SAM. Then in the exposure part, we are using the HRV recording due to the assigned narrative, and then HRV is again taken. So in the demographic profile, just a second. Yeah. So this was the inclusion and exclusion criteria. Normal or corrected to normal vision. No history or neurological or psychiatric conditions were there. Familiarity with the basic storytelling formats and provided written consent was taken for the participant. Ethical approval was taken from IIT Mandi Ethics Committee. Participants received one academic credit upon the completion. The educational background of the participants were mostly they were from undergraduate background. Master degree 20% has been taken, and in the doctorate 3.3% has been taken. So the three conditions which are there, the first is VR condition. So the Harish Chandra story was developed in the post spaces education for the Harish Chandra storytelling format, and VR headset Meta Oculus Quest 2 has been used for the data collection. It was the story was made in third person perspective. The experience was passive, 360-degree immersive visual and auditory narrative was shown to the participant. In the reading condition, Harish Chandra's story was presented as a plain text document. The format was standard literary prose and delivery was digital document on the standard display. So in the comic condition, Harish Chandra's story was adapted into the comic book format, and the visuals were sequential panel with the integrated caption, which was the dialogue and caption in the dual coding format. And the delivery was taken by the digital document on the standard display. So if you see the figure number one, it shows the VR condition. If you see the figure number two, it shows the text condition. And if you see the figure number three, it shows the comic condition. The story of Harish Chandra in summary is that King's Harish Chandra story was taken from Markandeya Purana, reflects his unwavering commitment to truth and sacrifice. Tested by sage Vishwamitra, he gives up his kingdom and endures immense hardship with his family, yet never strands away from his principle. Moved by his integrity, the gods eventually restore his life and kingdom. The measures and analysis which were done. So HRV measures were collected. The two measures which we have focused on RMSSD and LFHF ratio. RMSSD is the root mean square of successive difference. It is a short-term variation in the heartbeat, and the LFHF ratio is low frequency to high frequency power ratio, and it requires the balance between the sympathetic and parasympathetic nervous system activity. That is a stress and calm balance. The tools and software that we have used is QPS HRB was used to process the data, and SPSS was used for the statistical analysis. We have done the repeated measures ANOVA to compare the post-intervention HRB across the group, and pre-intervention values were used as covariate to control for the baseline measure. Significance level was kept at 0.05. So in the subjective and objective measures, we have used the PANAS scale. So in this scale, there are 20 objectives which are mentioned. If you see the figure number 4 with PANAS scale, the questions are on the Likert scale, starting from very slightly or not at all to a little, moderately, quite a bit, and extremely. So 10 questions are on the positive outcome and 1 questions are on the negative outcome, and it captures the positive effect, for example, pleasure, and the negative effect, like distress. And we have administered it pre and post exposure to the Harishchandra narrative. In the heart rate variability, we have used the EM Wave Pro device, which is reflected in figure number 5, and RMSSD and LFHF ratio, two of the heart rate variability factors we have used. This has been data has been collected pre and post after the narrative exposure. So data analysis was done using the SPSS, and we have used measures of ANOVA, repeated measures ANOVA, and post-op text has been applied, and the significance level, as mentioned, 0.05% we have kept. So the result according to the psychological outcome PANAS that we have kept is, if you see in the figure 6A, the main effect of groups on the positive effect score, and in the B, we have mentioned the main effect of time on the negative effect score. So in the 6, in the main effect of groups on the positive effect score, we have tried to see if the VR reading and comic are giving, is there any significant difference between the group. So we saw that VR sensory reflex richness gives an initial thrill in the positive effect, whereas reading and comic, they are also showing the positive effect, but in terms of ratings, that magnitude of change within the group, we see that comics give a comparable shift from the baseline, even if the post scores remain low. So, in the heart rate variability results, the first is 7A, the main effect of groups, which is VR, reading, and comic on the RMSSD values, and the second is the main effect of time on the RMSSD value. So, while the VR and text group reportedly significant higher RMSSD value, reflecting more parasympathetic activity, balanced sympathetic activation was slower for comics. This reflects active cognitive processing rather than poor engagement, shows that comics optimize the trade off between the mental effort and emotional calm. And for the LFHF ratio, figure number 8 shows the main effect of group on LFHF ratio and the main effect of time on LFHF. The comics registered the lower LHFF ratio, reflecting smoother cognitive emotional processing and greater autonomic balance. Comics had the lowest LFHF ratio, indicating smoother sympathetic regulation and less cognitive stress than VR or text. So the
Excuse
key
me, Mr.
finding,
Soni. This is just a gentle reminder that we have crossed the 9-minute mark.
yeah, okay.
Please continue.
The key findings are that balanced engagement, text and comics delivered smoother autonomic regulation alongside self-reported effect, matching or surpassing VR's emotional engagement. Although VR elicited the higher immediate positive effect, it also elevated LHFA ratio, revealing a contradiction where sensory emotion increases pleasure but reduces the physiological stress. Cognitive manageability, self-paced dual-fold format preserved the narrative coherence, enabling deeper reflection compared to higher load demands of VR. Comics significantly boosted RMSSD from baseline despite active processing, demonstrating the capacity to engage vehicle pathways and support calm attentiveness. So these findings challenging the emotion that more emotion means more impact on assumption, and highlight comics and text as effective, culturally grounded media for meaningful stress balanced storytelling. So conclusion, low tech efficiency, simple media like text and comics can rival and outperform VR in sustained emotional engagement, challenging the more emotion, more effect assumption. Application focus, recommending leveraging structured culturally background format for educational, therapeutic, and heritage storytelling to optimize emotional and cognitive. So in the future work, we can also focus more on, we can integrate EEG and additional HRV devices like SDNM and others with LFHF ratio alongside to capture the richer neutral autonomic dynamics, diverse story and auditory, test across varied narrative genres, and more heterogeneous participant sample, examine cultural and demographic effects. This also has applications in the real world. We can implement longitudinal classroom or therapeutic intervention to assess how sustained exposure to text, comics, or VR influences learning, retention, and well-being. If we can also explore hybrid format like animated comics, 360-degree videos, and varying interactivity levels to identify optimal balance between emotional and cognitive engagement. We would like to give the acknowledgement to the IEEE Sparks grant for the funding and Indian Knowledge System and Mental Health Application Center of the Indian Knowledge System Division, Ministry of Education, Government of India. Thank you. These are the references which were used.
Nice presentation, Vitika.
Thank you.
You are elaborated how your work is good, but I want to know, is there any limitation?
Yes, ma'am. Thank you for the question, ma'am. Ma'am, there are certain limitations. First of all, ma'am, the size of the sample is low. We have only kept 10 participants in each condition. For the other aspect, I think if the sample size is more larger, then it will be helpful. And the story that we have used is in the Indian context. If we use a story which is globally recognized, I think it will have a more generalized impact on the society.
Okay, thank you.
Thank you
Thank
so
you.
much for your presentation, ma'am.
Thank you, ma'am.
Moving on, I would like to call upon our next presenter. Our next presenter is Devashi Kute, presenting a paper on the title Parameter Effective Folk Art Generation, Fine Tuning, SELX and LoRa for Madhubani Art Generation. I request you to kindly take over with your presentation, please.
Hi, is my screen visible?
Yes, ma'am, now it is visible.
Good morning, all. I'm Devashri Kutte, a final year in computer engineering student from Cummins College of Engineering for Women. And along with my co-author, Professor Anjali Naik, I'm here to present my research on parameter efficient folk art generation, fine-tuning SDXL with LoRa for Madhubani art generation. So this work explores how AI can help preserve traditional art forms like Madhubani using modern lightweight techniques. This is the agenda. Text to image generation is like one of the most exciting things AI can do today. And models like Stable Diffusion XL are trained on billions of images and they can create stunning visuals just from the text prompts. But the catch is that these models are trained on modern Western style images. So when you ask them to generate something in a traditional Indian style like Madhubani art, they fail. Madhubani art is a folk art from Bihar and it is passed down from generations. Teaching AI to understand this kind of art usually needs thousands of training images and very powerful hardware. So my research focused on solving this issue. This research uses LoRa, which is a lighter method for fine tuning, and we managed with just 6 Madhubani images. And we also made it multilingual, so the model understands prompts in Hindi, Bengali, Telugu, and English. And to keep this style consistent across language, a custom tokenizer was used. And we have checked the results using a clip-based scoring method to see how well the images matches with our prompts. And this fine-tuned model is also published at Hugging Face Library. So this is the literature review. When we look at the existing work, most recent models like SDXL do perform better than the older GAN-based approaches, but still they don't handle cultural or multilingual prompts well. Some papers have also tried things like Dreambooth or Difflora for personalization for fine tuning, but these approaches also require lots of compute power and they don't transfer styles effectively, especially for art forms like Madhubani. Also, there is a lack of proper evaluation methods. That is why this research fits in the goal to combine LoRa, that is fine tuning, and keep the style consistent, all with limited data and hardware. So this is the methodology. The goal was to generate Madhubani style images using stable diffusion XL in a way that's both efficient and accurate to the traditional style. And to do this, the model was fine-tuned using just 6 high-resolution Madhubani images. Those were of sizes 1024 by 1024 pixels. And to make the process smoother, we used a blip model which captioned these images. And we also integrated multilingual support using Google Translate API. And a special token called Madhubani style was preserved throughout the prompt. And the pipeline runs on the Hugging Face Diffuser library with LoRa integration via PEFT. Also, FP16 precision and CPU offloading was made possible so that the training was made on a regular GPU. And a patched VAE module was also used to keep images crisp. To measure the quality, we have used clip-based scoring, which calculates the similarity between the input text and the generated images. And from the course of 500 training steps, the clip score improved from 28 to 35.1. And we also ensured that this evaluation worked across all supported languages. So this is the multilingual LoRa fine-tuning pipeline for Madhubani style generation using SDXL. This is the input box where 6 Madhubani images were fine-tuned. And then we did the blip captioning to generate the text for each image. And then the text and image pairs were generated. The next module is the multilingual prompt module where we have used Google Translate API and a style token fallback. Also, we have the LoRa fine-tuning module, which has stable diffusion as the base model, and the LoRa weights were injected into the unit. And then a patched VAE, FP16 SDXL, FP16 offloading was used. And at last, the clip score was calculated for the generated images using the clip similarity score. You can see the graph here, which illustrates how the training turned from 28 to 35.1 final score with over 500 training steps. Let's have a look at the implementation. So to begin with, we had the 6 high-resolution Madhubani artworks. These were selected from public repositories, and then each image was manually checked to ensure the authenticity. And then the blip model was used to caption those images. Then for the fine-tuning setup, we have this base model called Stability AI, Stable Diffusion XL Base 1.0. Then LoRa modules were injected into the unit architecture using the PEFT toolkit. And the training was done for 500 steps with a batch size of 1. Then a mixed precision FP16 training and a patched VAE were enabled, and all the prompts were used during training, which had a custom token called Madhubani style. And to ensure inclusivity, we had used Google Translate API, and this is the technical configuration and hyperparameters which are discussed here, which are displayed in this table. Let's have a look at our results. So you can see here that the generated image from the same prompt, that is Madhubani style to peacock in a village with bright and vibrant colors. The first image here generated here is using the pre-trained model, that is Stable Diffusion XL base. And we have another image generated using the fine-tuned model, which is Madhubani style LoRa. And you can clearly see the difference between these two images. Similarly, visual samples with prompts and clip-based scoring was also used for evaluation, and an average of 35.1 clip score was evaluated. So the model successfully learned and it was able to generalize well, and the clip score was an average of 35.1, and human evaluation confirmed strong stylistic fidelity in the outputs. Let's have a look at the conclusion. So, a resource-efficient pipeline was developed using LoRa and SDXL for the Madhubani style generation. The system also supported multilingual prompts in Hindi, Bengali, Telugu, and English. And it also retained those key artistic elements, which were bold lines, geometric borders, symbolic motifs like lotus, elephants, and flat color. And the model generalized effectively well even with limited training data. The fine-tuned model is also published in at the Hugging Face library, which is named as Madhubani underscore style underscore LoRa. You can find this in at the Devashri Kutte repo. Also, the limitations for this research was that the small data set also limits the creative complexity. Clip may undervalue the traditional non-photorealistic art styles. The future directions is like you can use digitalized museum archives to expand the data set, and we can adapt more culturally aware evaluation methods like domain tuned clip or human in the loop reviews, instead of using just clip. And we extend the pipeline, we can also expand this pipeline to other regional art forms like Warli art to support our digital culture preservation. So these are the references which I use throughout my research. Thank you all. This work shows how even limited data and lightweight tools can help preserve and celebrate traditional art in the digital age. Thanks a lot for the opportunity to present here. Also, a special thanks to my professor Anjali Naik for her inputs and motivation. Thank you.
Nice presentation. Thank you.
Thank you, madam.
Thank you so much for
Hello,
your
can
presentation.
I ask few doubts about that?
Yes.
For sure, sir.
Here, Devashree.
Yeah,
So, hi Devashree, very
thank
creative
you.
work, very nice presentation. I have
Thank
few doubts. Like, you had only 6 training images, no?
Yes.
So, from 6 training images, how did you train your model? Like, from the inputs, different prompts did you generate for these 600? Then you backtrace the model.
Yeah. So the thing is, when we fine tune any kind of model, it
Yeah.
requires thousands of images.
Hmm.
So instead of working from the scratch, we have
Hmm.
this base model, like the stable diffusion model, which I use.
Hmm.
And then I have used this LoRa technique. So what happens in LoRa? It is like a sticky note. You just
Hmm.
uh, you just do this small training on the 6 images,
You
and then
built
you
upon that.
yeah, and you
Yeah.
build that. Yeah, so in that way you can do this.
But even for that, I guess six are very less, no?
Yes, actually the problem is about the hardware. For
Yeah, I
the
got it.
training, for the
Google
training,
Colab will not support. It will,
yes, yeah.
yeah. Yes.
For
Same,
this,
I faced the
yeah,
same problem while fine tuning, so only I was curious.
yeah.
So
So
what
this
was the SDLX size, model size?
SDXL model size that was trained on around 10,000 images.
No, no, GB, like on disk, you train
Uh-huh.
using Hugging Face.
Yeah, yeah,
It
yeah. So the GPU which was used was NVIDIA RTX 3090
okay, don't got
Yeah.
it. Thank you. Thank you very
Thank
much.
you.
Thank you so much for answering that query. Now we'll call upon our presenter, Ms. Debunisa LH Malik. Ma'am, I request you to please take over with your presentation.
Can you see my presentation, ma'am?
Yes, ma'am, it is
Yeah.
visible.
Uh, uh, Good morning to the chairman, respected chairman, and all the dignitaries. My name is Zebunisa Malik. I'm the author of this paper, Generating Realistic Synthetic Data Using Corgan and Balanced by Smooth for Better Distribution. This is my, just a this is the introduction to ASD and data challenges. Actually, I'm doing research on autism spectrum disorder. My research model is predicting fine motor deficit in autism, but it was very difficult for the data. Data was a challenge. So this paper is related to the data collection model and based on the available data. So introduction. In this introduction, autism is a neurodevelopmental disorder. Like in autism, we have social interactions, communication behavior deficit, then behavior deficit. Mine is totally related to the fine motor deficit, where the autistic children have a disorder related to fine motor deficit. Now, symptoms are like in autism, symptoms are from mild to very severe also, but ours is a mild disorder. And we use machine learning here to help in the early and accurate diagnostic. Decision making will be easier. So accurate diagnosis requires advanced machine learning models, and for advanced machine learning model we need the good database, good data set. So however, we have an open source data set, but it is often very limited. So the problem statement for this paper is there is not enough open source data available online to study autism properly. Because of this, it's hard to build machine learning model, because we all know that if big data is there, the model will train nicely that can accurately do the predictions. So here actually I'm using the algorithm addressing data scarcity with CoreGAN. Now, what is this CoreGAN algorithm actually? So this algorithm is a conditional generative adversarial network algorithm actually, and to generate synthetic data. Now, what is synthetic data? That is the data which is there, but it is the artificial data, fake data, and this enhances data set size and diversity, and which will improve the machine learning model performance for ASD prediction. So now here, when we apply GAN algorithm, core GAN algorithm to the original data set, so this GAN algorithm will generate new data point and which will produce 100% more data point. So in this, why this GAN is there? Because see, our data is like I have a data of 704 data set is available, but this is also again small. Why? Because data is imbalanced, and in that data, I have 70 out of 704, 27% is only ASD cases and other is non-ASD cases. So it is very difficult to do the classification based on the machine learning algorithm. So here I am using CoreGAN algorithm for realistic synthetic to generate realistic synthetic data. Now, the purpose, again, I said, okay, because of this algorithm, we can generate the more data. And my research objective is to clean the available data, open source data set, because there is the noise is there. Then generate realistic synthetic data from given data set. Then apply the smooth over GAN generated data, and also one more algorithm, that is adaptive sync, that is ADA sync over GAN data, and prove that which algorithm is better on GAN generated data, smooth or ADA sync. So this is the experiment actually. Here is the proposed methodology. And in this proposed methodology, first of all, I got the data from the Kaggle dataset repository, ASD raw dataset, where it is 704 records are available. Then we apply the EDA algorithm. Now we know that what is EDA algorithm actually, it is the, sorry, EDA is not the algorithm, it is the technique. What it does actually, it gives us the critical first step, exploring, understanding, visualizing the data. So we need to understand, visualize the data using the EDA technique. Then data is clean, and then on that clean data, we have to apply the CoreGAN algorithm on a new clean data set. And after applying this GAN generated data, this synthetic data is generated. Now we know that how this synthetic data is actually generated. So here you can see that there are two two algorithms, ADASync and smooth. So smooth and ADASync. Why we are using this two algorithm? Because smooth and algorithm and ADASync both are oversampling algorithm. Because my database is data set is 704. Out of that, only 27% is ASD cases. So I need to do the balance of the data. So I will apply synthetic data generation for synthetic on synthetic data. I will apply the ADASync algorithm and smooth algorithm, and I will do the oversampling to the minority class. Okay, and then this is the experimental result. This is my data set, imbalanced data set. As I said, I have 705 records. Out of this, 5 and 5 is class 0, that is no ASD. And 189 record is ASD. So this data is imbalanced data, and in imbalanced data, classification algorithm will not work properly, and for prediction it will be very difficult. So hence this imbalanced data, again what we need to do the balancing for the data. So how to do the balancing? For balancing, we apply two algorithm again, smooth and ADASync. So both are oversampling algorithm. Smooth is uniform oversampling and ADASync is adaptive oversampling. That is the name ADASync. And smooth is simpler. ADASync is slightly more complex, and both are using doing the nearest neighbor using the nearest neighbor algorithm. So you can see the result here. My original data set was 704. Autistic, non-autistic was 189. Autistic was 515. Total it is 704. So with the CoreGAN algorithm, what it does, it will do the 100% more data. And this is the synthetic data generated. right? Now this is 1019. Exactly, you can see the double of this data, but again the data is imbalanced, so we applied smooth and adhesive. So this is only not the experiment. What we did after performing this experiment, and we measured the evaluation, we did the accuracy, precision, and recall. So here the data set is generated using core GAN algorithm. Accuracy, the generated data accuracy is 85.3. Applying adhesing algorithm, the accuracy will become 89.1, and applying the smooth algorithm, it is 91.7. So this is the experiment what we did, and then after that, we collected the actual data. So here the cross domain validation is done because we have to collect the original data also. Model is trained, and now to check if our model works well in the real world, we tested it on a completely new data set, that is 60 autistic and 60 non-autistic teenagers. So this was done, this was taken 6 months to collect the 60 autistic and 60 non-autistic data teenagers. Again, since this is the medical problem, so I did the good clinical practice exam also. I completed that exam. After doing that, one of the doctor is also involved in this for collecting the data, because it is not easy, and we need to go to the hospital and collect the data with the help of doctors also. So the Dr. Amina, she was there with us for collecting the data. So data was gathered with the help of help from the doctors and behavioral therapists. And after collecting that data, we used our train model, which is already we have done with core gain and smooth, without retaining to test how well it performs on unseen clinical data. So again, you can see that with the experiment, cross domain evaluation performances again. So primary data set, it was 97. As you can see that this was the 97 accuracy, and F1 score is 91.4. Precision is 90. At the same time, with the clinical data set, we got the accuracy as 89.6%, 88.2% precision, recall 90.1, F1 score is 89.1. So you can see that there is a slight drop in performance, which is expected due to the domain differences, because here the clinical data set is the actual data set. Again, it is very less, 60 is very less. And this is the limitation actually. The model retains high accuracy again with this data also, demonstrating strong generalization to clinically validate data and supporting the practical applicability of the proposed approach. So the conclusion is, we used an open source data set from the UCI machine learning repository published on 24 December 2017. On that AQ10 data set, our approach was to apply the combined core GAN with smooth and adhesing to improve the data set and model training. The result shows core GAN plus smooth and core GAN plus adhesing both improve prediction performance, but smooth performs slightly better in recall and F1 score, which are key in handling imbalance data. This proves that smooth over GAN generated data creates a more balanced, realistic, and useful data set. So this leads to better machine learning model performance, especially for ASD prediction. Now, both smooth and adhesing, both are like this. This is the main algorithm here we are using. In our data set, smooth is performing good as compared to adhesing. And this is like based on, because of this result, now again we have started collecting more data and applying the algorithm. This is the references. And any question and answer? Hello, am I audible?
Yes, ma'am, you're audible. Dr. Desai, do we have any questions for ma'am?
No question, ma'am. Thank you.
Thank you so much, ma'am. Thank you so much for your presentation, ma'am.
Thank you, ma'am. Thank you. Thank you very much. Can
I
I
would
stop
like,
sharing?
yes, ma'am.
Can I stop sharing?
Please, please, yes.
There is no question?
No,
Okay, thank you.
thank you, ma'am. Now I'd like to call upon our next presenter for the session, Advait Jadhav, presenting a paper on the title Retrieval Augmented Generation for Grape Leaf Disease Diagnosis and Treatment, a Deep Learning Approach. I request you to kindly take over with your presentation, please.
Hi, am I audible?
Yes, you're audible, sir.
Okay, thank you. Just give me a second. Just give me a second. Okay, so Our paper is titled Retrieval Augmented Generation for Grape Leaf Disease and Treatment, a Deep Learning Approach. I'm from International Institute of Information Technology, and I'd like to give uh, I'd like to mention our guide, which is Dr. Sonali Patil ma'am. Uh, uh, the main objective or the main problem that current agricultural faces or farmers face are well, there are multiple problems that are present, such as soil quality deterioration, pest control, plant disease, rapid spread of plant disease, climate variability. And in our paper, we focused on one of these, that is plant disease detection and providing accurate remedies for such diseases. Uh, so main objective is to create an unified AI-driven system using deep learning approaches, large language models, and CNN models to create accurate insights so that farmers and agricultural specialists can effectively treat any diseases that they encounter in okay, so the main limitations which we found in the traditional practices was uh, manual inspection and use inspection was done a lot of the times, which led to rapid spread of diseases which could have been prevented earlier if uses AIML system, which could detect instantly when diseases could were approached. Emergence of data-driven solutions such as IoT devices, drones, and sensors have opened avenues for real-time data collection, which allows us to instantly and accurately predict diseases and provide remedies regarding them. And the main kicker, that is the LLM technologies, which allow us to gather large amounts of data and present them in a readable format so that we can provide sustainable uh, recommendations to the user. So the main approaches, there are two different parts that we are unifying in our paper. That is the CNN approach, which is to detect plant diseases, and the other is the LLM approach, which allows us to gather that data and using LLM and retrieval augmented generation to create accurate insights regarding that particular disease. In the CNN section, there are multiple approaches that have been tested, such as efficient net architecture, VGG architecture, or mobile net architecture. On our testing, we found that the efficient net B0 model, for now at least, on our data set, provides the best of both worlds, that is model size and accuracy, whereas MobileNet, while giving us a lesser model size, which can run on edge devices, did not provide as much accuracy. And VGG, while giving a slightly better accuracy of 99% to which it gave us model sizes which could not be run on edge devices, which is the main point of this uh, research. uh, After that, the main issue with LLMs is that they require, well, you need to be constantly connected to the internet. Like ChatGPT, you have to go on the internet, type your query, and then it gives you a result, which is time consuming, may not be possible in remote areas where internet connectivity is not guaranteed. So to combat that, we used an local LLM, a small sized LLM, that is a Llama 3.18 billion model, which can be run on your device without any internet connectivity by using Olama or some similar software. Uh, then the main crux is that to so this is our proposed architecture. The main section, that is plant disease prediction, which we use efficient B0 model for. We have a data set containing over 9,000 images that we combine using a Kaggle dataset and real-time images to provide much more to provide much more, what can I say, real world capabilities. It is pre-processed and augmented. We have done some contrast efficient limit of histogram equalization to create much more contrast in image quality, helping us determine disease spots more effectively. Then we have the RAG system, which is the main point here, the retrieval augmented generation. Now, retrieval augmented generation is an LM technique in which we provide context that is retrieved from accurate documents to the LM so that it can give proper results. Now, LMs suffer from a phenomena called as hallucinations. Hallucinations are basically when the LM makes up information it does not know just so that it can answer your query. This can be very harmful in critical applications, especially when we are trying to provide information regarding how to treat a plant disease. It could lead to ruining the crops. It could lead to soil degradation, and it is something that we need to avoid at all costs. And in comes RAG, where we convert our textual data, that is any documents containing information regarding how to treat a plant, what are the pesticides to be used, what type of care should be taken after you apply pesticide. All of these documents, we convert them into vectors. Now, these vectors, we convert them into a vector using an embedding model. We have used an Hugging Face embedding model, which is open source. And then those vectors need to be stored somewhere so that we can access them easily. For that purposes, we have used a vector database such as ChromaDB. Uh, ChromaDB allows us, it is an open source database which is a vector store. It allows us to efficiently store our vectors which are converted from a document. These vectors are retrieved using a Llama index, which is a framework provided for LLMs. These retrieved context is then fed to the our LLM model so that it gets enhanced clarity regarding what is the problem, what should be the solution, and it presents them in a human readable format, which is understandable. It is all connected using REST APIs. So the predicted plant disease is sent to the Llama model or the RAG model. The RAG model then searches the vector database for any knowledge regarding that particular disease, such as, let's say, black rot. It has a query that it vectorizes and searches using similarity search. It is then sent to the model, which uses that as context to provide accurate remedies or recommendations on what to do next. Yeah, this so the main what can you say? It is a scalable solution. So if right now we have done this only for grapevine diseases to provide to as a prototype to get accurate results if it properly works or not. But this can be easily extended using models for different plants such as tomato, potato, anything which can be detected using images. It can be extended to. Another great feature about using LLMs is that we can add additional information by ourselves, such as climate, soil information, to increase the accuracy of our readings and our and the output. Again, because we are using a lightweight LLM, such as an 8 billion parameter model, as opposed to, let's say, the GPT-4, which contains like more than 500 billion parameters, it can be installed on edge devices. It can be installed on sensors and mobile phones without having internet connectivity. We can integrate plant, soil, weather information, allowing us to uh, gain better outputs. It also, by using efficient net along with a lightweight LLM, the response times and detection is reduced to in a fraction of a time if you use other heavy models, allowing like faster interventions. Again, the model is scalable. Like I said, you can add different detection models to the existing framework and have it work perfectly fine, because we are using REST APIs for communications, and uh,
Excuse
documents
me,
can.
sir. We have
Yeah.
exceeded the 10-minute mark. I request you to
Okay.
kindly wind up as soon as possible.
Okay, so let's move on to the results. We trained our efficient and D0 model on over 9,000 images. We got an accuracy of over 98%, but I would like to preface this by saying that majority of these images are from a lab tested environment rather than a real world images. We have additionally added around 300 images of real world images for transfer learning to get more actionable results. But further, we are limited by the data set that we have. Uh, this is the actual output that we can get. As you can see, it gives us a summary of the disease causes and typical impact, recommended treatments and best practices, and how we can prevent future measures. This all of this data, while we have found that to be mostly accurate, will need to be further verified by agricultural experts and fine tuned, so that we can get a we don't actually mess things up for the farmer. uh, yeah, so this future, the future scope is again, you can integrate pest monitoring, soil assessment and weather forecasting. Field trials with farmer feedback are necessary to get proper evaluation. Yeah, and at the end of the day, the goal is to get a smarter, adaptable, and AI-driven agriculture, so that food security and farmers can cultivate crops without worries. Thank you.
Nice presentation, nice topic, Advait.
Thank you.
Can you elaborate the adaptability you have said now, which is your goal?
Yeah, so like the current architecture that we have, here a single rack system can be supplemented by documents regarding all the different crops that we have. Currently, we're only doing this for grape wine because again, training takes a long time for a CNN model. But in the future, let's say we have data set regarding tomato. Like if you're on a tomato farm, you want it regarding to tomato. So we can take all the data that we have, train a model regarding tomato, and just instead of here this module, plant disease prediction. Here instead of grape line, which we just add a tomato data set and we are good to go. So it can be adapted to different agricultural contexts.
Okay, thank you. One submission from my side, you can approach to different agriculture officers.
Yeah, yeah.
They may help you. Okay.
Yeah. That is something that
Thanks.
we are.
Thank you.
Uh,
Thank you so much for your presentation, sir. Now I would like to call upon our next presenter for this session. Our next presenter is Athira T, presenting a paper on the title Seeing Through the Green Veil: How Greenwashing Perceptions Shape Sustainable Consumer Choices in India. I request you to kindly take over with your presentation, please.
Good morning, everyone. Am I audible?
Yes, ma'am, you're audible.
And is my screen visible?
Your screen is visible, but I guess there is some lagging, ma'am, because your voice is breaking a bit.
Is it okay now?
Yeah, it is okay now.
Okay, so can I start?
Please, yes, please.
So good morning, everyone. I am Adira from Amrita School of Business, and presenting my research, that is Seeing Through the Green Veil: How Greenwashing Perception shapes sustainable consumer choices in India. So this was co-authored or a collaborative effort with my co-authors, that are Abhishek, Dr. Deepak Gupta, and Shobna Madhavan. So there is a trend in raising environmental awareness, which has encouraged sustainable buying behavior. But this trend has also led to greenwashing, that is the false claim and exaggerated environmental claim that companies do. So our study looks into how factors like environmental knowledge, moral obligation, social influence, and skepticism affect greenwashing perception, green purchase intention, and sustainable consumption behavior. For this, we got data from 223 Indians, and we analyzed it using SEM and MedSem with Stata 15. And one of our key findings is that perceived moral obligation is the strongest predictor of a person's green behavior. So consumers now are more inclined to buy eco-friendly or sustainable products, and brands are exploiting this by giving their exaggerated claims about their eco-friendly image and their products being more sustainable. This has created a confusion and mistrust among the consumers. There are a lot of studies, but there is lack of how Indians are responding to the perceived greenwashing, and like India is culturally diverse, and their moral values and social factors, and we want to know how these moral values, social factors, etc., shape up an Indians like how Indians perceive the greenwashing. So from literature review, we got to know that greenwashing perception affects purchase intention and sustainable consumption behavior. Green skepticism reduces trust in sustainability claims. Social influence shapes greenwashing perception and sustainable behavior, etc. From the literature review, we found gaps there are limited insights into how Indian consumers respond to greenwashing, and the influence of moral values and the social influence, that's the external pressure on someone's behavior, is not fully understood. So the question comes, how does greenwashing perception influence consumers' consumption behavior and purchase decisions, and what factors contribute to shaping this perception? To understand this, we took help from two theories: value belief norm theory, which helps us to understand how perceived moral obligation drives green behavior among Indian consumers, and theory of planned behavior, which helps us to understand the attitudes, social norms, perceived control, etc., in shaping a person's purchase intention. These two theories combined together gives us an understanding of both internal values and external pressures in Indian context. This is the conceptual model which we came up with, where perception acts as the mediator. So these are the hypotheses which was generated by us, like green skepticism has a significant positive effect on greenwashing perception. Perceived moral obligation has significant positive effect on greenwashing perception. Greenwashing perception has a significant negative effect on sustainable consumption behavior, etc. These are the constructs, and each construct is well graded in literature and measured using valid scales from previous studies. So our research design was, we did a quantitative research with 223 respondents across India using an online questionnaire. We tried to collect the response from Pan India. We used SEM and MedSem in Stata to analyze the data. And the demographics of our sample predominantly comprised of young, urban, highly educated individuals, and almost we had equal gender representation. And most of the sample relied on social media for their primary source of environmental information. From the analysis, we found that social influence and perceived moral obligation are the strongest influencer on greenwashing perception, sustainable consumption behavior, and green purchase intention. So, and green skepticism directly does not influence sustainable consumption behavior or green purchase intention, but through greenwashing perception, it influences sustainable consumption behavior and green purchase intention. From this, we could say that moral obligation is the strongest influencer influencing all three dependent variables. Environmental knowledge influences sustainable consumption behavior, not the purchase intention. And green skepticism does not act directly on both the dependent variables. Social influences reduces greenwashing perception and enhances a person's sustainable consumption behavior and green purchase intention. And interestingly, we found that greenwashing perception directly does not influence both sustainable consumption behavior and green purchase intention. So what are the implications? Brands should focus more on trust, ethics, and clarity. They should move from claims to credibility. Like they could use QR codes, etc., link the certification and their reports to show authenticity and be transparent. Their messages should be around the ethics and values. As Indians, we are influenced more with our perceived moral obligation. They could talk more about fair trade, community upliftment, etc. And finally, they could collaborate with sustainability influencer or a strong community leader to bring out their brand. This gives better credibility, and social influence is one of the strongest influencer. What are the limitations? The study included only 223 respondents, which were mostly from the urban area and were highly educated. And the data was self-reported, and there could be social desirability bias in these data. And we did this research in a generalized product context, and there was no cultural diversity idea in our research. So in future scope, we could say that the research could be a long-term research where you could take time and understand their behavior, which evolves over time, and qualitative insights. They can have in-depth interview and have focus group, etc., to understand their emotional connection and their cognitive reaction to the greenwashing. They could have industry specific studies like FMCG, fashion, electronics, which would give an idea on a person's perceptions. And also, India being a diverse country, they could explore a state-wise, they could have a state-wise analysis or linguistic based or cultural group based, etc., which gives better idea on their social influence. These are my references, and thank you. Hello.
Thank you so much for your presentation, ma'am. Dr. Desai, do we have any questions for her?
Nice presentation, I think.
Hello, ma'am. Hello.
Okay, there is some glitch, I guess. She said that it was a nice presentation.
So any questions?
Do we have any questions for ma'am? No questions, I guess. So thank you so much for your presentation. Now we'll just move on to our next presenter for the session. Our next presenter for this session is Kayur Kurani, presenting a paper on the title The Dual Edge of AI in Cybersecurity, Mitigating Ransomware Threats Through Self-Learning Honeypots and Behavioral Analytics. I request you to kindly take over with your presentation, please. So Kurani.
Yes, am I audible?
Yes, sir, now you're audible.
Okay, so myself, Kayur Kurani, and my topic is Dual Edge of AI in Cybersecurity, Mitigating Ransomware Threats Through Self-Learning Honeypots and Behavioral Analytics. Now, what this basically means is we will be exploring two sides of AI. How can it be used in performing ransomware attacks, and how can we use it to defend against it? So, just a second. Yes. So we will start off with what is ransomware. Now, Ransomware is a type of malicious software that can encrypt or block access to a user's file or systems, demanding ransom generally in the form of cryptocurrency. Now, if a hacker performs ransomware attack on your device, you have to pay money so that hacker releases your own personal files. It can be done through phishing emails, it can be done through malicious downloads, or it can be also performed through software vulnerabilities. Now, uh, to understand the extent of these ransomware attacks, we have to take consideration of one case study, which is WannaCry attack. Now, this attack was performed by a group of hackers by exploiting Eternal Blue vulnerability in Microsoft. As we all know, there are many vulnerabilities in any operating systems, which we don't even yet know. So it infected through the Eternal Blue vulnerability and affected over 2 lakh devices across many countries. Now, our research objective basically focuses on how we can defend against these attacks with the help of artificial intelligence. Now, first of all, what if the hacker doesn't get a chance to even attack your system? That's what honeypot does. Honeypots are basically decoy systems. You can say fake systems, which can act as real devices to the hacker, so that hackers actually think that they have actually hacked their systems, but in reality they have not. Now, traditional honeypots are out of date. Many hackers can breach through them. So we are going to discuss adaptive AI-based honeypot systems. Now, what I have done is I have actually built a Flask app, basically a ping tool for experimentation. A ping tool can be used to ping to a particular device. Now, when here's a breakdown of how our adaptive honeypot works. Now, it simulates open ports and services in real time. Then we can use ChatGPT to connect with the ping tool. Upon connecting to the ping tool, the hacker can inject its queries, mostly malicious queries. Now, upon injecting the queries, if the system finds that the code contains any malicious stuff, then it directly connects to the GPT-based reverse shell. Now, if attackers try a reverse shell attack, our system traps them and collects that behavioral data. And they are actually very successful as compared to static honeypots, as they give us rich behavioral data. Now, my partner has performed this experiment of evading detection through polymorphic malware. For that, she has used Android ransomware detection dataset from Kaggle. The model she has used is XGBoost. The purpose to use XGBoost is because it gives a better result for structured data. And we have achieved accuracy of up to 94.17% in evading these attacks. Now, how this research helps us in evading attack? Our detection model, which used the XGBoost algorithm, it is great for handling structured data and finding complex patterns. We used dataset from Kaggle for pre-processing, which included scaling, encoding, and cleaning the data. Then we split data into 80-20 ratio, 80 for testing and 20 for validation. Then we evaluated accuracy and precision. And we got a strong accuracy of up to 94.17% defense rate. Now, going upon the conclusion, ransomware is evolving rapidly, as we all know, with the help of AI. And our case study, WannaCry, showed how vulnerable it is. So we cannot no longer use traditional tools to evade against those attacks. And that's why we are using AI-based honeypots as well as AI-based modification code techniques to evade those attacks, which shows higher accuracy. Now, what is the future scope of it? Like I said, we use the XGBoost model to evade detection through polymorphic malware and honeypots as well. Now, further, we can also, in this research, to extend this research, we can also include deep learning models like convolutional neural networks for deeper analysis and detections. We can also create real-time dashboards for constant monitoring of attacks, like at what scale these attacks are happening and how can we defend defend ourselves against such large scale of attacks. We can also perform some betterments on our honeypot systems, like we can integrate it with cloud environments, which can increase its capacity substantially, and use other AI options other than ChatGPT, more efficient AI options specifically for these reverse shell processes. Okay, that's all from my side. Thank you. Any questions?
You implemented this system?
Yes, I implemented honeypot system.
Okay. So
The model
WannaCry,
was, yes,
can you elaborate a little bit related with the WannaCry?
yes, ma'am, I can.
It is vulnerable.
Okay, so as I said, WannaCry was a ransomware attack. Now, there was a vulnerability in Microsoft Windows. It was called Eternal Blue. Now, as I said, there are many vulnerabilities. If any vulnerability is known by the attacker, which can be actually searched using artificial intelligence, people are not using vulnerabilities like traditionally, one by one. They are using AI for detecting vulnerabilities. So likewise, they detected Eternal Blue vulnerability and infected over 2 lakh plus systems, as those systems were using Windows. And that's how they got inside the devices of those people and encrypted their files. So that now, if they want to access those files, they will have to pay ransom to the attacker. And that's why I provided solution of my honeypot systems. Basically, now those 2 lakh systems were hacked, right? So what if we could provide an additional layer in front of those 2 lakh systems, so that attacker thinks that they have actually hacked the systems, but they have not in reality. So that's how my research works. The research part is basically this ping tool and the adaptive honeypot system, which I've used. Yes, ma'am, I'm done. Am I audible?
Yes, sir, you're audible. Thank you so much for your explanation.
Okay, any questions?
Ma'am, do we have any further questions? Okay. Thank you so much, sir. Now I'll just call upon our next presenter for the session.
Okay, ma'am, thank you.
Sorry, ma'am, you were not audible.
Due to technical problem, thank you.
Okay, ma'am. I'll just call upon our next presenter. Our next presenter is Sarthak Baralia, presenting a paper on the title Web Application Firewall Using Machine Learning and Features Engineering. So if you are available with us, I request you to kindly take over with your presentation, please. Mr. Sarthak Baralia. So if you are available with us, I request you to kindly take over with your presentation, please. Okay, I don't see sir in the chat box or at the participants column. So with this, I think we come to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for the support during the 10th version and all other previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All presenters would be given their digital certificates through email within the 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I would like to thank our session chair, Dr. Latika. The, I would like to thank our session chair, Dr. Latika Desai. Ma'am,
Thank
this is a
you.
token of appreciation from our side, ma'am. Before concluding this session, would you like to say a few words?
Hello. Every researcher has presented their presentation very nicely, and all the topics are catchy topics and useful for the societal use. And I have observed all have taken the care of the time limit too. So all the best for your future research. And it is not the end; it is just the start. So there is a lot of scope to work ahead. All the best for that. And thank you, GR Foundation, ICT4SD team for giving me an opportunity as a technical session chair. Thank you, Aman sir, Amit sir, Richa and Rashi. Have a good day. Thank you.
Thank you so much, ma'am. Thank you. This is a token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, ma'am. Now I request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual conference we just had to save it as a memory. Requesting all our participants and guests to kindly please switch on to your cameras so that we can take a screenshot or our virtual session. All participants, we request you to kindly switch on to your cameras. Thank you so much for your valuable presence. We'll meet you in the next sessions in 2026. Thank you so much. You all can log out. Thank you so much.